A positive integer n has base 11 representation a, b, c, and base 8 representation 1, b, c, a, where a, b, and c represent not necessarily distinct digits. Find the least such n expressed in base 10. Okay. So the first thing I'm going to do is write out exactly what it means for a number to be represented in a particular base. So this says the number n is equal to a times 11 squared plus b times 11 plus c. And this is also equal to 1 times 8 cubed plus b times 8 squared plus c times 8 plus a. Okay, and we want the smallest value of capital N that satisfies this. So I think the first thing I'll do is simplify, rearrange some things here, and see what we can get. What is 8 cubed? $512? I thought it was larger than that. Did I do something? Hold on a second. I'll verify that one real quick. That's okay, 512, fine. Okay, so now I have an equation that a, b, and c have to satisfy. A, b, and c have to be numbers less than or equal to 7. They have to be between 0 and 7 because we're given this number in the base 8 representation. So these digits have to be 7 or less. But let's also rearrange and do some cancellations. So I have 120a minus 53b minus 7c minus 512 is equal to 0. Now the smallest value of n, which makes this possible. I think now I might just be going for trial and error. So A has to be large enough that 120A certainly has to be greater than 512. Does 5 work? A is equal to 5. So this gives me 600 minus 53B minus 7C minus 512 is equal to 0. In this case, B would have to be equal to 1. Let's put the 512 on the other side. I feel like it would be easier to make things add to 512. B is equal to 1 minus 53 minus 7C. So this is what, 547 minus 7C is equal to 512. is at 35. So C is equal to 5. So I have A is equal to 5, B is equal to 1, C is equal to 5. And I think this is going to be the smallest possible number, because if I make A any smaller, 4 times 120 is 480, which is less than 512. So we won't be able to, the right-hand side of this would already be negative. Okay, so this says that n is equal to 5 times 121 plus 11 plus 5. And that's just going back to the base 11 representation of the number. So this is 605 plus 11 plus 5, 610 plus 11, so n is equal to 621, and that's the smallest number that allows for these base 8 and 11 representations. Yeah, so there wasn't really anything, just a combination of a few special things here. The first is understanding exactly what it means to write a number in a particular base. It's just about adding up multiples of powers of that base. And once we have this written down, I wasn't sure exactly where things were going to go, but the first natural thing to do would be to simplify it into a single expression like this. And then I realized, because we're looking for, there might be several values of A, B, and C that satisfy this, but because we're looking for the smallest possible value, the first thing I wanted to do is choose the value of A here to be as small as possible, such that we even have a hope of solving this. And if I was not able to, if I substituted A equal 5 and was not able to find values of B and C which worked, then I would have moved up to A equals 6 and tried again, and so on. So I was just always choosing, the smallest value of A, which gives us any hope, then the smallest value of B, which gives any hope, and so on. And it looks like we ended up with the unique answer. So I hope I didn't make any mistakes here, but if I find an error, then I'll write about it down in the description. Thanks for watching.